This is Building Effective Images with Abby Fuller. Abby is one of our most popular DockerCon speakers ever. She's an awesome evangelist at Amazon Web Services, and we'll just let her finish her own introduction. Take it away, Abby.
Hi, everyone. I am Abby. I am from... Thank you. I'm Abby. I'm from Amazon Web Services. We are here to talk about something very glamorous today, and that is disk space. So if you guys were promised an interesting session, I'm sorry. We are just going to talk about disk space the whole time. I have gotten dire threats about staying on track for time, though, so we are going to rock right ahead. So agenda. So what are we going to cover today? So we're going to talk about how layers work. We're going to talk about the basics for building minimal images. We'll cover some high-level best practices for Windows containers. We'll talk about some Docker files. We'll get language specific. We'll cover a couple tools, and then we'll talk a little bit about the future. I'm not going to stop for questions at the end of the session today. If you want to catch me for questions afterwards, I will stand out in the hallway during the break, and that way we get a little bit more time because we do not have a lot. So without further ado, how do layers work? So what are container layers? So we're getting back to basics, but how are containers built up? And when I start off with an image, I pull a base image. So in most cases, that is a stack of read-only container layers. So they're added on top of each other. I cannot do anything to them. So those are the base image. In a lot of cases, that's the operating system. So I might pull an Ubuntu image. I might pull a custom image that I've made myself. I might pull an Alpine image. I can't do anything to them, and that's what makes up the base of my container. On top of that, I get a thin read-write layer. So there's not much to that. Any data that I produce when I'm running my container, any configuration that I do to it, that all gets added to the very thin read-write layer on top of those read-only base layers. So why do I care about how many layers that I have? So more layers mean a larger image. So the larger the image, the longer that it takes to both build and push and pull from my registry. So why do I care about that? It means faster deploys, faster builds. It also means a smaller attack surface. So the less that I have in my container for someone to attack, although I guess now we've resorted to just attacking WPA2 and Wi-Fi, but the less packages that I have in my container, the less there is for someone to mess with. So that's why I care about it. So the more of them I add together, the longer it's going to take to push. And this is especially important because we've gone from for a lot of people, you used to run a monolith, right? So you had your one application stack. You maybe deployed it once a week, every couple of weeks, something like that. But you didn't deploy very often. So the fact that those deploys might be very slow and fragile wasn't super important to you. But now, if you do microservices, you do containers, you're deploying lots of little pieces many, many, many times a day or a week. So if you have a slow build, it's added up pretty quickly. So how can I reduce the number of layers that I have? So we're going to go back to preschool, but sharing is caring. So use a shared base image wherever possible. So if you have a bunch of Node.js containers and they all have pretty similar requirements, use a shared one. Make a custom container, share it among the containers, and then each little service container just has the configuration that it needs. We talked about that thin read-write layer. Limit the data that you write there. So if you don't have to write data, don't limit your configuration. Try to keep them as small and kind of uni-purpose as possible. Chain your run statements. We'll dig into that in a couple minutes, but if you can add things together in the same layer, you're not adding to the overall size of that container. And then we'll talk about this in greater detail also, but prevent your cache misses at build for as long as possible as well. So building minimal images. So let's cover some of the basics. So this is day one of DockerCon, so I think some people are probably still new. If you don't know by now, now you know. A Dockerfile is a series of constructions for building images. If you've never worked from them before, they usually follow something like instruction and then command. So from image name, run command. Pretty simple. We'll look at what they look like. We talked a little bit about preventing cache misses as long as possible. So my apologies to Wu-Tang, but it's not cache, but it's cache rules everything around me. So this is probably the single most important thing to take away from this. So Docker uses the cache both aggressively and also very uniquely. So make sure that you one, go and read the cache documentation. So do not learn everything from a Wu-Tang slide that I gave at a conference. But you want to prevent mishing your cache as long as possible. So anything is going to stay the same between one container build and the next, push off your run statement as long as you possibly can. So all my things like label or maintainer or from, those things all go first, and you keep them first, and then you add what's going to change afterwards. That way you're not needlessly rebuilding things every single time you pull your image just to get to the part that's changing. So keep that part where you're actually going to change what's happening. Keep it from happening as long as possible. There are some exceptions. So if your run statement is unchanged, it usually uses the cache, right? So if you're pulling something from a repo, that command is going to be the same every single time, but you actually want that to happen. So make sure that you look at the actual documentation and see where you might want to break the cache earlier than expected. But in general, make sure that you're using it. It's the single fastest way to speed up your builds and get smaller, faster containers is to make sure that you're caching what you don't need to redo every time. So as promised, let's start with the Dockerfile. So this is pretty basic. So I moved to Docker a couple years ago. I was at a startup called Airtime, and we started off with a Node.js monolith, and we broke it down to a series of microservices. This is something that I totally would have written when I first started out. Why is this something that I would have done? So it does the job. This builds correctly. It builds from an image, a base Ubuntu image. It uses latest. So latest is, for a lot of people, it doesn't really mean anything, but a lot of people use it as the convention to say that this is the most up-to-date version of the container. And that's not always what we should be doing, but this is pretty sensible. I started off with an operating system that I was familiar with the latest and allegedly better version of that operating system. I labeled it really nicely. I added some packages. I installed some packages. I copied my code over. I installed some more requirements. I exposed my port, and I called it a day. So this is fine. It's not great, but it's fine. It works. I probably would have been really happy with it. And then at 2 a.m., a couple months later, I would have gotten woken up by all of my servers. And they would have said, but I don't have any disk space. And I'd be like, but I use Docker now, and Docker solved all my problems. So how can I be out of disk space? And that is because although this works fine and it builds just fine, it's not great. So how are some ways that we can maybe make this a little bit better? So my first step, choosing the right base. So I have my stock Ubuntu image, and look at how big it is. It is 458 megs, and that is also fine. But what happens when I now have 10 of those containers? I have 12, I have 15, I have 100. My 458 megs, they're making a much bigger difference than they did when I maybe had just one monolith. So my example is using Python. So let's use an Alpine container. I pull latest from there. That's 86.8 megs. So just by switching to a base image that's slightly better qualified for the actual use case that I'm doing, I can save myself a bunch of space. That space will save me a bunch of disk space on my servers and will prevent me from being paged, which is always my ultimate goal. So slightly better, what could we do on top of that? So we looked at different bases. Here's a couple of examples pulled from Docker Hub. The base really matters. So that set of read-only layers that you're writing on top of, those are all important. And maybe you can't do anything with them, but they're still adding to the total size of your container. So use something that's both right for your specific use case. Try to use the smaller one if your case is right. And we'll talk a little bit about when maybe it's not right to use a smaller image. So when do I want a full base system? So when do I actually want an OS? So this is where I apologize to Ubuntu for using them in all my bad examples. It's not you, it's me. So when do I want a full OS? So one is security. So Wi-Fi notwithstanding, a lot of people using this minimal system or rolling their own, that's not going to work for them security-wise. So you're not really sure where it's coming from, or it doesn't have the package that you need. Your company hasn't approved it. The same with compliance. So not everyone works in a startup. So if I work at a larger company, I work in banking, I work in finance, I work in healthcare, I maybe can't use whatever base image is the most popular on Hacker News right now. I have to use a full OS for compliance. And the last one, there are other reasons, but these are the three that we've used, is ease of development. So we'll look at this a little bit later with Ruby. But using a more minimal image can mean some extra work. So it doesn't necessarily have a package manager. It doesn't. You're used to in the kind of traditional server world. If I SSH to an EC2 box, I usually can expect a couple things to be there, right? So it might have curl, might have wget, it might have some stuff on it. But if I'm using a minimal image, all that space had to come from somewhere. So there's not necessarily the same packages, gems, requirements that I might have when I use a full operating system out of the box. So we'll look at our original image. This is the same one that we used before. Again, it just works. So how can I get some bigger results? So my first one is I've changed the base. So I'm now using that Python Alpine, and you'll see that one of my lines has disappeared. I'm no longer adding some of those requirements, and that's because rather than starting from kind of a blank base OS, I'm using one that was built for Python. So it has some of the packages that I already need. So I've slimmed down my base to going from a minimal kind of base image that's more suited for my use case. And then I'm moving over just what's different for me. So my app code, and I'm running my specific set of requirements. So this makes a fairly big difference and was not a whole lot of work. So I actually took away work by finding the base that worked better for me. I've made it both smaller and then a little bit better. So fewer cache invalidations. So I'm just copying a file here. So that file itself, like the name of the file, isn't going to actually change. So I've moved it over a little bit. I'm just preventing my cache invalidation from happening just a little bit later. So I'm getting a couple steps out of the way, and then I can do what's changed at the very end. So that way, I'm not adding another extra step after I've invalidated the cache that I didn't need to save until later. So I can do the same thing with my application code. On build is another thing to definitely dig in a little bit into the documentation for, but I can use that to add my requirements also. That way I add it when my container is actually built. So another way, make it a little bit smaller, make it a little bit faster, and push off what's different until I absolutely need it. So we'll take a little break, we'll recap. So layers represent these file system differences, and they add up really quickly, and they have really significant consequences. So a little change that's maybe just one line, that's maybe a couple megabytes, it's not that big of a deal when it's just, when you're just one container, or you're just starting out, or if you're just learning how to play with Docker. But they can add up really quickly in a real-life production deployment environment. So you have to be really conscious of that. So some high-level best practices. So the last DockerCon in Austin, we celebrated kind of the first DockerCon with Windows. So some of these are probably not news to some of you, but what are some ways that we can deal with Windows? And the first one is I can port over my existing VM workloads. So actually, it's on YouTube. Elton had a great session on this at the April DockerCon, so go look for that. But you can convert your existing Windows images, and you can run them in Docker just like you can anything else. So I can run convert to Dockerfile, and then you'll look and you see that my last two commands, so that Docker build and Docker run, they are exactly the same as they would be for a more traditional Linux container, right? So it came from Windows, but it is exactly the same, and I can run it exactly the same. A couple of things to think about. So these are still my favorite gotchas, but watch what you build. So Windows is not Linux. So be really careful of the paths that you use when you're building your image. So building any of these will make your image very large and you'll have a very bad time. I did this and I don't recommend it. So definitely be really careful. So actually even more careful than you would on Linux. So make sure you're looking at the path and you're building only what you need to. And avoid installing packages with MSI. So if you've used Windows, MSI installations, they work fine. They are not space efficient. This is not the same as a Linux distro. So we'll look at the example, but in Linux, I can add, use, and remove an installation file in the same step. So if I add something, if I add curl, I use curl to get a package, and then I remove curl, it hasn't added to my final image size. Only the file that I've used curl to get has been added because I've used it and removed it in the same layer without adding it to my base. That does not work for MSI. So Windows saves those MSI files for uninstalls, which you're familiar with. So if you've used Windows, you can do like the double click thing to uninstall or like the right click to uninstall. that will come back to haunt you a little bit in containers because it will save that file. So even if you add use and try to remove it in the same step, it will not quite work the same as Linux. So you still have to go back and remove that file, and it still would have been added to your final image size. So coming up soon, there was an article in the Docker blog about this, so I would check that out. But there's some new stuff out around Windows servers about running Linux containers as is. So definitely something that's we're continuing to add to this. They're getting even closer to kind of being able to run things exactly the same way, regardless of the operating system that you came for. This is really cool. So this is a huge shift, and I've only seen this getting more and more powerful over the last couple of years. But build and run everything exactly the same, regardless of container OS, your host OS, or your tools. Just Docker build and Docker run. Keynote doesn't like when I use GIFs, but this is Shia LaBeouf saying this is magic. It is magic. So regardless of whether I have Windows or Linux or whatever, I should be able to build and run my container infrastructure the exact same. I'm not a Windows expert. Usually I call out to Elton's escaping the VM, but rudely enough, he did not offer it directly after me this year. There are a lot of great Windows sessions, though. So if you're looking for some Windows-specific tips or if you want some news about Windows, definitely go check out those sessions with some of the experts instead. So Docker files, the good, the bad, and the bloated. So this is the same image. We've all seen it. This is exactly how I would have written it at the beginning. And you'll see that I've moved out my 2 run commands. And I can tell you exactly what my thought process would have been doing this, which is I am so nice. I am a documentation gift to everybody because look at how neatly this is. I could comment every line. Everything starts with the command. It's really pretty. It's formatted really nice. And I would have been like, look, developers, look at what beautiful thing I have given to you. I am not as much of a gift as I thought. So how can I chain those run statements to make my image build a little faster and build a little smaller? So I've changed my run statements, and we noticed that we added those as one of our high-level things at the very beginning for what I could use to make my container smaller. So I've added them together. So I'm doing my update and my install all in the same place. And I've also added another flag. So if you're familiar with apt-get, there's a flag that says no install recommends. That way I don't install the recommended packages. So I don't always need them. Sometimes I do. But what I would rather do is if I'm trying to build a more minimal image, I'm going to add only the packages that I need and not just all the ones that Ubuntu thinks I might need. So I've added that flag and I've chained my run statements together, which will make my image a little bit smaller. I can then try my different base. So this will also make it smaller, right? So we've picked the base that's better for my use case, and I'm only installing the requirements that I just need. So that's it. These are some pretty small changes, though. And I think that one of the goals here is that to be able to leave the session thinking that here are a couple things that I could go do myself right now. So not a lot of research required for these, but take a couple looks through your images and say, okay, here's where I might be able to get a little bit of space. Here's where I could make my builds just a little bit faster. Here's how I could get more out of my deploys. Another way to do this, so a custom-based container. So I've made my own base in this example, and you'll notice that my initial steps are also gone, right? Because I've installed the requirements that I need because it's my base container. So I've built it somewhere else. I've added the requirements that I need. It has all the setup that I want, and then I'm pulling it from my ECR registry. So that's a good example for people to try also because you can build exactly what you need without needing to use what someone else has built first. Here's another example on how I can get a little bit more out of my run statements. So I run apt-get update, I run install, I add the tools. I've pinned a couple of versions because I don't necessarily want it to grab the most recent version if that's not something that I actually need. And then I've added one more step at the end, and that's cleaning up the contents of varlib apt lists. So I'm both updating, I'm installing, and then I'm removing the installation files that I used to install those packages. And I'm doing that all in the same layer so that anything that I don't need isn't added to the final image size. So switching user adds layers also. So if you SSH into a server, then you might switch user when you're installing something. So some things might be it's one user, you add a new DockerCon user, and then you switch it. That actually adds layers. So every time you switch your user, you commit a new layer. So if your image is something like Node.js and it comes with its own user when you install it, use that user. Try to avoid switching layers where you can. The same with adding large files, right? So we have a bad example, a better example, and a best example. My bad one, it adds a file, it runs the contents of that, and then it runs make. So how I could make that better, I could run, I can get my file, and then I can do make all in one line, or I could be a little bit better. I could do that all in one piece. So in the previous examples, I'm adding extra steps because every time, once I've broken that cache, it's over. So now I'm already committing to the final size of that image. Avoid adding those big files where you can. So now I'm doing run, tar, and make, and I'm removing it all in the same line. So I've used it, I've installed it, and I've cleaned up my mess. So I've made it just a little bit more minimal. So let's get language specific. A couple of high-level best practices regardless of language. So my first one, use the right tool. So not every language needs to be built the same way, and we'll look at a couple examples for this. But where possible, maybe use two images. So one to build an artifact and one to build from base. We'll look at this with Ruby, but official language images can be really huge. So more space effective to use a more minimal image, but there are trade-offs. So our first stop is Golang. So compile, then copy binary. So I can run go build, I can run Docker build. And then from my Dockerfile, I can do from scratch. And we're going to talk about scratch in just a second. But I can copy over my contents, and then I can run it. So I'm just running the binary that I built right before this. Plus, it has a cute gopher. Quick detour. So what is scratch? So it is a very special empty Docker file. I can use it to build my own base image, or I can use it to run a minimal image like we did in the last example that runs a binary and nothing else. So it might look like this. So from scratch, I'm copying over hello, and then I'm running it. By the way, brief digression, this slideshow has links in it, both as the slideshow goes and then at the end. So won't be really helpful while you're sitting in the office, but in the audience. But I know that people download these after the fact and like to look at them at their leisure. So there are a bunch of links. So if I've used something, I've often linked to the either official Docker documentation, or I've included a section at the end that will point you to some of the blog posts and some of the official pages and videos that people can use to educate themselves more about this on their own time. So back to business. So Ruby, I've been mentioning this a couple times, but official images for Ruby are extra huge. There's a reason for this. A new base and a little extra work will pay off. So when you use Ruby, every gem seems to have a bunch of other gems that it needs, which is true. But that makes the official image really big because they've tried to account for having many of the gems that you'd need to run your dependencies. So it makes them really big, and it's good in one case, right? Because you don't have to do a lot of development work. You can pretty much assume, okay, so if you're trying to get started quickly, you can pretty much say, okay, I have this image, and maybe it will just work, right? It'll have a lot of the gems that I need. It'll have a lot of the dependencies that I need. If you're trying to make it more minimal, maybe try a new base and maybe put a little extra work into it. So from here, I can do from Alpine. You'll see that I now have to add a lot of things that I could expect came out of the box with some of my more full images. So I'm adding curl, I'm adding bash Ruby, I'm adding Ruby dev, I'm adding bundler, and then I'm removing some of my cache files after I've installed them. So a little bit of extra work, but I could make this image a lot smaller than the official one. Next up is Node.js. So this is also another real life mistake that I've made. You can Docker ignore. So works just like git ignore, but you can Docker ignore npm debug .log. And then most importantly, you can cache your node modules. So you can ignore some of these files that you don't need. They'll make it extra huge. My example here is copying over my package.json. It's running npm install, and then it's copying that over. So that way I'm only running npm install if my package.json changes. Here's Java. So there was it's been out for a couple of months, and we talked about this at the last DockerCon. But multi-stage builds are your friend. So you can build an image from another image. So I'm running from Maven 3.5 as build, and then I'm using copy from build as I build that. So like the Golang example, this lets you build an artifact in one stage and then run that binary in the second stage. So that ends up with a more minimal final image because I'm doing kind of all of my heavy lifting in the first part. And then I can do my second part, the more minimal part after that, and it makes my actual run a lot faster. Here's another multi-stage build example. Basically, there's a ton of really great blog posts on this, and there's a couple of really good examples. I think Arun has a whole workshop on doing Java with multi-stage builds. But I can do my from Ubuntu as my build env. I can do all my make work. I can add my stuff. And then from my second Dockerfile, I can just copy from all that work that I did in step number 1. So definitely dig into this. For things like Java and Golang, where you have a lot of toolchain work required to build something, but not required to run it, this can be really great because you can do all of your heavy lifting in part 2, and then you can just run that fairly small binary in step 2. So tools are here to help. So there's a lot more work that comes with running these containers, right? So I've gone from maybe one giant piece to many small moving pieces. So documentation is extra important. Automating where possible is also important. So this is where you get into things like orchestration tools and deployment pipelines and templating. There's a lot of work that can go into running really good containers and microservices. So make sure that you're automating where possible, but also where plausible. So you're not just kind of automating away, but that you're making good processes, and then you're giving yourself a little extra help to automate them if you need. Make sure things are secure, make sure they're resilient, make sure that they can scale. So moving to containers does not kind of solve all of your problems, right? So doing smaller containers will be better deploys, smaller attack vectors, but security first, make them resilient, make sure that you can scale this. And I think you get one of the coolest things about containers is being able to scale different parts of your services independently. So if I have one service that, doesn't do a whole lot, maybe it's like an internal admin dashboard, doesn't need to scale. But since I've written my containers correctly, I can deploy maybe a messaging service that needs to scale all the time. I can deploy it all the time. And if I've used minimal images to make my deploy even faster, I can do that all the time as well. And then I can lean on some tools to give myself a helping hand. So one of these is Docker Security Scan. So you can see this on Docker Hub. I promised everyone that I would make a better image for myself after last time, and then I didn't because this one's way better than mine. What's Docker Security Scan? So when I push images it works for some official images too, and we'll see that on the next one. But I can consistently run security scan that's checking for vulnerabilities in those images. And I think that's really important, right? Because if you're pulling someone else's image from Docker Hub, you want to know that it's safe. So what this ends up looking like is I've scanned a bunch of images, and then I can dig into what those vulnerabilities are and what security scan has found in those images on Docker Hub. So you can do it yourself. It works for the official images, but another tool that's kind of there to help you make sure that what you're doing is safe. A couple different options here as well. So image prune and system prune. So image prune is going to get rid of dangling images. So that's images that are untagged that you're not using for anything else. So we'll look into this in a couple different cases, but this is really important. So even if I built a really minimal image, I don't want it hanging around for forever if I'm not using it. So I can use image prune to clean up all those dangling images. I can go even further with system prune. So system prune will get rid of all unused and untagged volumes as well as images. So I'm both writing my minimal images, I'm deploying often, but then I'm making sure that I clean up my mess afterwards because I probably don't want them hanging around once I've already used them because that's space that I could be using for something else. So the importance of garbage collection though. So beyond just system prune and image prune, make sure that you're cleaning up after yourself. So make sure that your orchestration platform, so like ECS or Kubernetes, is garbage collecting. I added some links like I did before, but make sure that you have tools out there that are cleaning up after the things that you're not using anymore. So unused images, unused volumes. Make sure that you're cleaning up after yourself. There's also some third-party tools. So Spotify makes a good one, Spotify GC, that you can run to extra garbage collect just in case. Looking forward to the future. So there's always new and better things coming. So we talked a little bit earlier about Linux and Windows servers. So official images being multi-platform. There's always new and better minimal images and operating systems coming out for containers. So we've talked in the past about being able to build your own OS with Nix. There's always new ones. So we looked at Alpine. There's a ton of ways out there. This is something that part of what's really great about an ecosystem like containers that are growing, it's growing so quickly and so many people are participating in, is that there is a ton of people working on stuff like this. And if you're having a problem, like you want a more minimal image, there's probably someone else working on that as well. So the Docker community is great for things like that. But there's always someone else working out on, okay, so how can I get even smaller images? Because it affects everyone. So being able to have quicker deploys is kind of a problem that everyone wants. I don't think I've ever had someone come up to me and been like, my deploys are too fast. My images are too small. So now what do I do with my time? So there's always room to optimize. There's always people working on that. There's always things coming out from the community to help you make your images even better. So what did we learn? So a little bit of a recap. Some takeaways. So less layers is ultimately more. So we prevent breaking our cache as long as possible. We chain our run statements. We can use our shared base images. Choose or build your base wisely. So that might be something like either using a specific, like a language specific image. So like Alpine or the Python version, it might be building your own base image, or for a lot of people, even though it's less minimal, it might mean using the full operating system because you have security and you have compliance. And then we can look for other optimizations, but make sure that you're using the tool that's right for you. Not all languages should build the same. So multi-stage builds are really powerful, right? So for Golang and for Java, those are all things that I can do all my heavy lifting and then I can run just the binary, but maybe that's not right for everyone. Maybe you can do it without multi-stage builds and you didn't want the extra step. But make sure that you're using ultimately the tool that's right for you. So build your image in a way that's going to be secure and scalable and minimal for you. Keep it simple, avoid the extras. We looked at that with apt, especially with the no install recommends. You don't always need the recommended packages. You don't always need something extra. In some cases, maybe you can reuse the same tool. Maybe I had 2 ways to get files onto containers, but I rewrote something and now I only need 1. So I can keep it simple. I can avoid extras. And then there's a ton of community tools that are out there that can help you build and run your images smaller and faster. So as promised, I included a bunch of useful links. There's a ton of stuff not in this presentation, though. Also, hallway track, there's a bunch of hands-on labs. There's a bunch of really great sessions, both after today and tomorrow also. Some links if you're following along at home. So if you are looking through the presentation later, I've called out to a bunch of examples and documentation so that you can learn some of these things in your own time and put them into practice. That is it for in here. As promised, I will hang out afterwards, or I can take a couple questions now, actually, because I think I got some extra time on the timer. So I will take a couple questions now, and if you don't want to ask your question here, I will be outside afterwards. So if you have a question, feel free to raise your hand and I will, or I guess just shout it. What? Oh, there's a microphone in the center of the hallway, the path down the middle. So if you are exiting, please exit to the sides. If you have a question, you're welcome to come to the center and answer it, ask it. Okay, so I will stand here. Thank you. I told you.